Hey guys, I'm here to do lesson 6.3 with you. Let's get started with your learning target. After this lesson, I will be able to understand expressions. Remember that expressions are number sentences without an equal sign. Let's get started with your think about it. When you take a taxi, the driver charges an initial fee when you start a ride, and then an additional charge for every mile driven in the cab. Lisa is taking a taxi to the airport. When she gets in the taxi, the meter already shows a fee of $3.50. After every mile, the cost of the ride increases by another 50 cents. Lisa figures that she can use the expression 0.5 m plus 3.5 to find the total cost of her trip to the airport. The table below shows how much it would cost for her to travel 0, 1, and 2 miles in the taxi using that expression. So for your think about it, it wants you to determine in the expression 0.5 m plus 3.5, what does 0.5, m, 3.5, and finally 0.5 m represent in the problem's context? Explain how you know. So go ahead and pause the video and look back at your text and see if you can figure out what each of these represent. All right, guys, hopefully you paused. Let's go ahead and get started. We'll start with 0.5. If we come back up to the text, where does it say 0.5? It says, after every mile, the cost of the ride increases by another 50 cents. So the 0.5 is representing the 50 cents charged for each mile. So this represents the 50 cents charged per mile, or for every mile. M. Well, what do you think M stands for? M is going to represent the number of miles that Lisa rode in the taxi. So this represents the number of miles Lisa rode the taxi. Okay, the 3.5. If we come back up to the text, it's talking about the meter already having a fee of $3.50 on there. That's actually that initial fee. Since as soon as she gets into the taxi, that's what she sees on the meter. So the $3 or the 3.5, this represents the initial charge to start a ride. Okay, and then finally we have 0.5 m. Well, it looks like they're just putting two of these things together. We got the 0.5 and we have the m. So 0.5 m in that case, then that's going to say the total that she's going to pay for the number of miles she rides in the taxi. So 0.5 represents how much Lisa will pay for the number of miles she rides in the taxi. All right, let's go ahead and move on. All right, guys, let's go to our key point. Mathematicians make sense of expressions using blank and the problem's blank. What do you think it is? Mathematicians make sense of expressions using vocabulary and the problem's context. Variable, a letter that represents a value. So again, it's a value that we don't know what it is yet, so we use a letter to take its place until we figure it out. So going back, which of these is our variable? Well, this is easy. We know this. Our variable is m. So this is a variable. A coefficient. The coefficient is the factor multiplied by the variable in an algebraic expression. For example, in the expression 4a, 4 is the coefficient. So if we go back to our think about it, which was our coefficient? Which is the number we multiplied by our variable, m? That's right, the 0.5. So this is a coefficient, an example of a coefficient. Term. A term is a known number, a variable, or the product of a known number and a variable that make up an expression. So if we come back up here to our think about it, which of these do you think is the term? It's this one. So 0.5m, that's one of our terms. Okay, and last but not least, we have the constant. And a constant is a fixed value or number that stands on its own. So if we come back up here, which one is our constant? The only one that's left, the 3.5. All right, let's start with our interaction with the new material. Every day, Jeff runs with his dog to keep in shape. He always runs 3 miles in the morning and 5 miles at night. He is able to run each mile in the same number of minutes, which is represented by the letter M. He always takes a 20-minute break at night to play catch with his dog. The expression 8M plus 20 represents the total number of minutes Jeff spends with his dog each day. Identify the terms in the context and explain what they represent mathematically and in the context of the problem. So let's start by marking up the text. I'm going to highlight this time instead of use my pen. So it says he always runs a total of 8 miles, 3 in the morning and 5 at night. So we're looking at a total of 8 miles. Okay, and then we have to multiply the number of miles that he's running by that variable M, because that's going to tell us how many minutes it takes him to run those 8 miles. Okay, so we're looking at 8M. Okay, let's see, he always takes a 20-minute break at night, so that's important. And then we have the expression, which represents the total number of minutes he spends with his dog each day. So starting at the front, we've got 8M. What do you think 8M is going to be using one of these vocabulary words? Well, if we look back at our previous example, the number that had the variable attached to it, that ended up being our term. So that's going to stay a term. Okay, we already know that M is a variable. And then this 20-minute break, this is something he does every night. So this is going to be a constant because it's constantly happening every time. Then looking at our actual expression, 8M plus 20, we have 2 different terms. We have 1 term and 2 terms. So there's 2 terms. Okay, what vocabulary word are we missing? Let's see, we've got variable. We've got do we have coefficient? No, we don't, but we can figure that out. Remember, the coefficient is the number that is multiplied by a variable. So if I'm looking at the variable, what number is multiplied by it? 8. So 8 is actually going to be our coefficient as well. So let's make sure we've used all of those terms. We have variable, we've got the coefficient, we've got a term, and we've got constant. All right, so let's go ahead and start answering. All right, so the term 8M represents the amount of time it takes Jeff to run those 8 miles. The 8 is going to represent the number of miles. And is our coefficient. Notice in my explanation, I'm using the vocabulary terms that we talked about. So 8 is our coefficient, not efficiency. M represents the number of minutes. And this is our variable. Okay, our second term, so we've already used this one, the first one. Okay, so our second term, 20, is a constant. And it represents the number of minutes Jeff plays catch with his dog. All right, so I'm going to go back and make sure that we represented each of the different terms. So we have the term 8m. Okay, so we've got term done. Okay, we talk about 8, which represents the number of miles and is the coefficient. So we have our coefficient done. M represents the number of minutes and is our variable. So our variable is done. And then finally our constant, which is the 20 minutes that Jeff plays with his dog at night. All right, guys, so those are the different parts of our expression. So you are going to use this to help you to solve the level practices. Remember, you're responsible for solving at least the 1 and 2 star. The 3 star is bonus if you want that extra challenge. Okay, so your criteria for success today during your independent practice is that you're annotating your problem and that you have an answer statement that is written. I'll see you guys during your class time. We'll talk